Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. This is the fourth installment in the Adventures with Python series, in which we learn Python by building a text adventure game. No prior programming experience is needed, but you should watch the series videos in order. I'll link the playlist here and in the description. Let's get started. In the last video, we created a data structure made of a list of lists to represent our dungeon. This allowed us to shorten our game engine to just 6 lines of code. But once the player chooses a direction and moves to the new location, the game ends. Today we're going to add a loop to this. A loop will allow the player to explore the entire dungeon until they choose to quit. So far, our program executes from the top of the script to the bottom, a flow of control we call sequential. It has some branching created by our if statements that allows us to execute a branch under certain conditions. For example, we will only try to move the player to a new location if the command they gave us is a direction command, and then only if there is a room in that direction. Otherwise, they stay in the same location. If their command wasn't a direction, they get a message, "I didn't understand that command." The branches allow us to execute code only under certain conditions, the conditions specified after the if or elif keywords. But once a branch is chosen and has executed, control returns to sequential flow of control, continuing to the end of the script. What we want is to be able to repeat code while a condition exists. In our game, we'd like to repeat the player giving a command and moving to a new location while they haven't given the command to quit. This is called a loop because the flow of control will return to an earlier line of code in the script, forming a circle in the flow of control, or a rectangle if you use straight arrows in your flowchart as I do. This is achieved with the keyword while. I'm going to create a new, much simpler script so we can focus on the loop structure, and then we'll incorporate our new knowledge into our game. And literally, we're going to add 2 lines of code to our game and remove and change some other lines to achieve this. It's a huge impact for just a couple of lines of code. I'll call my new script loop example, and I'll upload it to my GitHub repository with the other code from this series. There's a link in the description. I'll put a docstring at the top. Let's write the line of code that obtains the command from the user, and then I'll just print it back to them. So command equals input, what is your command? And then print you commanded plus command. And above I'll annotate command as a string. This code obtains an input and processes it, admittedly quite simply, but it's similar to our game in which we obtain a command and process it. Let's write a loop that will repeat this until the user enters Q for quit. Note that this is not something you can do without a loop. We could put an if statement after this, if command is not equal to Q, and then get another input, and then have another if statement. And we could do that many times, but we don't know how many times the user might enter commands before they enter Q. It does give us an idea of what code we want to repeat and under what conditions we want to repeat it. Okay, so to wrap this code in a loop, after I get the command, I'll write while command.upper, open close paren, is not equal to Q, colon. And then when I press enter, the cursor is indented, and I'll repeat the code obtaining and printing the command indented under the while. I'm comparing an uppercase version of the command to Q, so I can also accept a lowercase q from the player, but I'm not going to store an uppercase version back in the variable because I'm telling the user what they typed. It might seem odd to them if I show them an uppercase version of what they typed. After the loop, so at the same level of indentation as while, I'm going to put another print statement. And I did quit. I'm going to run this. It asks me, what is your command? That's the first input statement on line 7. I'll type N, and the code on line 8 executes, printing you commanded N. Now we reach line 10, the top of the while loop, and command.upper is N, which is not Q. So the test is true, and we will execute the indented code. In that way, a while is similar to an if. Keyword, condition, colon, and indented code that executes only if the condition evaluates to true. Line 11 executes, asking me for another command. I'll type look. Line 12 executes, printing you commanded look. And now, because this is a loop, control returns to line 10. This is where a while loop is very different from an if. Line 10 is the loop test, the header line of the loop. While command.upper is not equal to Q, and that's true. Look is not Q. So we went back into the loop body, and the program is executing line 11 again, asking me for my command. I'll type a few more non-Q commands. And you can see the program continues to execute lines 10, 11, and 12. When I finally enter Q on line 11, the program still goes back up to the test on line 10. It will always go to the test after the last indented line executes. This time the test is false. Q not equal to Q is false. And now we proceed to the first line of code after the loop, line 14. If we're on line 14, we know that the user entered Q. There's no other way that we can reach line 14. To reach the first line after a loop, we know that the loop entry condition, in this case command.upper not equal Q, must be false. While it's true, the loop will execute. That means, importantly, that there must be some code inside the loop, indented code under the loop header, that will change one of the variables in the loop entry condition so the loop can end. If we don't have some code inside the loop that will change the variable command, then we'll have what's called an infinite loop. The loop will keep executing because we haven't done anything to make that condition false. If that happens to you, and it happens to all programmers at some point in their career, type Ctrl-C to abort program execution. I'll comment out line 11 and show you an infinite loop. You can see how, after I type N, we reached the loop entry condition, it was true, and then the loop body executed, and then control went back up to the loop header, and the condition was true because we didn't do anything to make it false. And that would happen infinitely if we didn't abort the program from outside. Now I'm going to head back to our game and show you how to put basically this same loop around our code that gets and processes a command from the player. I've renamed this to shabbyabby v4.py. So, in our program, we should first identify the code we want to repeat. We want to obtain a command from the player, process that command, in this example, by moving them to another room, and tell them the results of our processing. That is a pretty standard game loop. It's the same kind of loop I write when I write a pygame game. It's just that in a pygame game, the command from the user is controlling a sprite in a graphical environment. I'm going to stick with our method of putting commands in a list. So at the top, I'm going to define quit commands as a list of strings consisting of uppercase Q and the full word quit. Down over the code I want to wrap in a loop, I can write while not command in quit commands, and then I'll indent the code that describes the current location, obtains a command, and processes the command by changing the current location to the new room if the direction was valid. That's a little different from our other test, by the way. That's how we test for a value not in a list. We write not, and then our test for a value in the list. The not will give us the opposite truth value from the expression after it. So if the player types Q, then command in quit commands will be true, and putting a not in front of that makes it false, and we don't go in the loop. That's what we want. We don't want to go in the game loop if the player wants to quit. If the player typed N, then command and quit commands will be false, and putting a not in front of it will make the expression true, and we will go in the loop and process that command. Now I can delete the code at the bottom where I print the current room again. Why? Because remember, we're going to always go back up to the loop header where we have the word while. And if the condition is true, we'll go back into the loop. So if the player chose to go south, for example, and we set current location to a new location accordingly, and then the test command in quit commands will be false, south isn't in quit commands, and we'll print that new location information at the top of the loop. Structuring the code inside a loop can take some practice. And, in fact, this loop won't work yet. Let's see what's wrong with it. We check if command is in quit commands at the top of the loop. Well, there's a problem right there. We haven't gotten a command yet. We can't test a variable that doesn't have a value. Notice in our simple loop, we got the command, then tested, then got the command again. I can do that here too. I can prompt for the command before the loop and then in the loop. If we prompt before the loop, there's actually a name for that, a priming read. Another option is to give command a non-quit value before we reach the loop header, so we always go into the loop the first time. I'm going to do that because it's less repetitive code that I might need to edit in the future. I'll set command equal to the empty string, quote, quote, with no space between them, up where I annotate the variable. So now we know command is the empty string, and that's not in quit command, so we'll go into the loop. We display the current location. I'll set that to 0, where we initialize current location, the cloister. And then we obtain a command from the user and convert it to uppercase as before. We check if it's a directional command, and if it is, we reduce it to the first letter, and if there is a room in that direction off of the current location, we change the current location to the index of that room. And then we go back up. If the player didn't choose quit, then we go back into the loop and display the new current room and get the player's command. Now, what if they do type Q here? Then if command in directions is false, so we go to the else, and the program prints, I didn't understand that command. We don't want it to print that if the player chose to quit. So let's rewrite that condition as elif not command in quit commands. Now it will only print that message if the player didn't choose a direction and if the player didn't choose to quit. So again, assuming the player chose Q, nothing is printed in the game loop. We go back up to the loop header and the test is false, and we drop out of the game loop. Now the final option is what if the player typed a bad command, like up? We get the up command. It's not in directions. So we go to the elif, and it's not in quit commands, so the program prints, I didn't understand that command. We go back up to the top of the loop, and up is not in quit commands, so we go back in the loop, print the current location again, and prompt for a command from the player. This loop works for both kinds of valid commands, and it also works well for invalid input. It responds appropriately to good and bad input. Now, for another loop example, you might remember that I said it was redundant to store both an exit string and a list of exits. Let's write some code that generates the exit string from the list of exits. I'm going to write this as a separate program for now. I'm going to call this program generateExitString.py, and I'll add a doc string and copy our Abby data structure in. I'll add a variable location, an int, and give it an initial value of 0. Our code will create an exit string for the location at that index. We can change the location to test different combinations of exits. Recall that in our data structure, for a single location, the values at indices 3, 4, 5, and 6 are the exits to the north, south, east, and west. A non-negative 1 integer is a valid exit, and a negative 1 means there's no exit in that direction. Let's pull the exit integers out of this list into a new list consisting only of the exits. We could use a loop to build that up, but Python will allow us to slice a list. Slicing a list means extracting a subset of the list into a new list. It's like indexing, but we can specify a range of values we want in our new list. I'm going to annotate a variable, exitsList, a list of int, and then exitsList equals Abby sub location sub 3 colon. The first index, location, will get me to the sublist that is the data for one location. Because we've set location to 0 for now, that will be the cloister. Now the second index is the slice. I'm specifying from index 3 through the end of the list. That's 3 colon. If I put another value after the colon, then the slice would be the data from index 3 up to but not including the data at the value after the colon. Let me print exits list and run the program. You can see it's a list consisting of the values at indices 3 through 6 at index 0 in our data structure. Now I'm going to create a parallel list of the words that I want in the string. So direction strings is a list of strings, and that's going to equal north, south, east, west. Why is this list parallel? Because the values in this list relate to the values in our exits list by index. The element at index 0 in exits list, 1, relates to the string north, and the value at index 1 in exits list, 2, relates to the string south, etc., for all of both lists. What I'm going to do is create a list of exits by looping over the exits list, and when there is a value that isn't -1, adding the parallel direction strings value to my list exits. So if I have 1, 2, 3, 4, then I'll end up with a list that is north, south, east, west. If I have -1, -1, -1, -1, then I'll end up with a list that's simply west. If I have -1, 0, -1, 1, then I'll end up with a list that's southwest. Let's write a loop that can iterate over both of my parallel lists. To do that, I want to create a loop control variable that will take on the indices of both lists and write the loop so it starts at the first index and ends at the last index. The indices of a list run from 0 through the length of the list -1. So I can annotate a variable I of type int. I is a common name for a variable that's going to take on a predictable sequence of values. I'll set I equal to 0. And then while I is less than len exits list : and then right now, let me just write print exits list sub I. And then, importantly, I need to increment I. So the next time through the loop, it will point to the next element, and eventually it will reach the length of the list and the loop will end. So I plus equals 1. This operator is a combination of addition and assignment, and it adds whatever the value is on the right to the value stored in the variable on the left and puts the result back in the variable on the left. So it's equivalent to I equals I plus 1. It's such a common operation that we have this special operator to do it, called an augmented assignment operator. Let's run that. And it prints the exits 1 to a line. Now, what I want to do is create a list of exit strings for the exits that aren't -1. Before the loop, I'll annotate and create an empty list called exits. An empty list is simply open, close, square bracket. Inside the loop, I'm going to check if exits list sub I is not equal to -1. And if it is not equal to -1, I'll add the value from the same index in direction strings to the list. That looks like exits.append direction strings sub I. And after that loop, I'll print exits. You can see it's a list of all of the exit words. Let me change our location variable to 1. That's the church, which has 1 exit to the south. Let's run it again. And now our list consists only of the string south. Let's turn this list of exits into an exit string now. I'll annotate a variable exits string. And that exit string is going to look different depending on how many exits there are. Let's start with the simplest. If len exits equals 0, we'll set exits string to there are no exits. There's nothing like that in our Abbey right now, but a player could certainly get themselves into a situation where there are no exits in a theoretical dungeon. Now, let's do the second simplest, 1 exit. These are mutually exclusive conditions, so I'll use an elif. Elif len num exits equals 1, and I'll set the exit string equal to there is an exit to the, and concatenate to that exit sub 0, and I'll add a period. Now, what if there are 2 or more? We could keep going with elif statements, or we could write a loop. A loop is better because we might want to include additional directions, such as up and down, in the future. But I'm going to write it with elif statements and leave writing it as a loop as an exercise for you. It's a little tricky as a loop because the last two directions are really a special case, so a loop mostly makes sense for a longer list of directions. Still, my loop code is only 4 lines long, and this is going to be longer and will feel very repetitive. So, elif len len exits equals 2, and I'll append into my string, there are exits to the plus exit sub 0 plus and plus exit sub 1 plus period. And I'll similarly build up long strings for lengths of 3 and 4. There, that's all the cases we have right now. If a line is going to be really long, it's better to break it up over multiple lines. But to do that, if you're writing an expression, you have to enclose the expression in parentheses. The line will be more readable if you put operators at the beginning of new lines and not at the end of a line. Now let's print that string and test it. For a location of 1, we get there is an exit to the south. Let's try location of 0. We get all 4 exits. I've written a testing suite that I'm going to paste in. This is an exhaustive list of all possible combinations of exits in the 4 directions. And then I have a parallel list of what the output string should be for each list in the suite. Usually we can't conduct exhaustive tests, and in that case, we would want to test edge cases, such as exits at the beginning and end of the list, no exits, all exits, exits next to each other in the list, and exits separated by other non-exits in the list, for example. I'm going to wrap a loop around my code to run all of these tests. So this loop will be another loop that's going to iterate over parallel lists. I'll use a variable called testNum to control it. I'll start it at 0, the index of the first test case, run while it's less than the length of the Abby list, and increment it at the end of our testing, and indent all of our testing code. I've just wrapped a loop around this code that will cause the code to execute a specific number of times. At the end of it, I want to print the string that was generated and the string that we expect to have printed, which is stored at output sub testNum, the parallel element to the test case. Let's run that. And we can go through and compare each result to what we expected and see if there are any test cases for which we did not get the expected output. And then our debugging work would begin. But this looks correct. We have looked at a few loop examples, but loops are often tricky for beginning programmers to master. I'm going to link a playlist here and in the description that goes into great detail about the different kinds of loops you might write and the different situations in which you might use a loop with lots of examples. I urge you to watch the videos in that playlist after you experiment with the concepts in this video, so you can have a well-rounded knowledge of loops. They are very powerful and you can master them with practice. I urge you to practice with loops, slicing lists, and looping over parallel lists. I recommend writing the loops we wrote here from scratch, only looking back at what we did today if you get stuck. You might try writing a loop that iterates over the Abby data structure and prints the name of all of the rooms. Ideally, that would work even if you add a room to the dungeon. Try adding up and down directions and modifying our string generating code to work with the additional directions. And create some parallel lists of your own and loop over them. For example, you could create parallel lists of monster names and other monster stats, such as hit points, strength, or descriptions. Ask the user to give you a monster name, and then produce all the stats for that monster by finding the monster in your name list, and then using that index to display information from the parallel lists. When you're feeling confident with loops, join me for the next installment of Adventures with Python. As always, have fun and keep coding.